All right, so we're back on a very happy Monday morning, and let's see. So I think, if I remember correctly, wasn't the exam due today? Is that possible? I'd have to double check. When I'm going to Moodle, I think my intention was to post an announcement. I don't remember if I did or I didn't. Let's check that out real fast. Now, I know a lot of people have been sending them to me by email, and that's great. So far, nobody's said anything about having trouble getting them done. In the sense, what I mean is the recording, taking the pictures and sending them back by email. There was maybe one person where the files were too large, but they were able to eventually get that straightened out. So if anybody has any issues, technical issues, I mean, should definitely let me know. I don't want anyone to be penalized because the technology doesn't work. Nah, I didn't put it in here, did I? All right. Well, anyway, I'll tell you what I'll do. When we're done, I'll go back and look at my notes and we'll see whatever the date is. I'll just post it on Moodle. I think it may have been today, but if it is, it's at midnight. So in other words, if you haven't finished it yet, you're still good. And so send it over here. Like I said, probably your quickest approach is to simply take photographs of your work with your cell phone camera, which I know you all have one. I don't have to even ask if you have a cell phone or not. Can you imagine that? It would be like asking you if you wear shoes or something like that. The answer is, of course, yes. So now, if there's a real problem, I mean, a genuine issue, let's say your phone camera is not working or there's some technical issue, like I said, you can just let me know and we'll try to figure out a solution. And also, if you're stuck in the questions, if you're not sure what's going on, you can certainly send me an email about that too. All right. So I hope it wasn't too difficult, that it was pretty much what we've been doing. And now we're diving into chapter 8 again, which is our discussion about interest rates, which is an especially important topic because you may never need the quadratic equation again for the rest of your life, but you certainly need to understand how interest rates work. That's for sure. You'll not be able to do anything in this society without encountering interest rates. As far as any transactions involving money, where you're either borrowing or lending, interest rates are going to determine how much it costs you to borrow or how much you can earn by lending. So that's just the way it works. And so understanding how much or how loans are determined, the payments that are attached to a loan is very important, or especially if you just got your first credit card. You may have noticed that the interest rate that they're charging you is actually quite large compared to other types of loans, which is, of course, because there's so much risk involved for the bank. In other words, if you choose not to pay your credit card bills, there's nothing for them to repossess. And so the risk is very, very high. Okay, so let's get back into it. And we'll get started from where we left off. Now, I do have one or two videos here that we might want to look at today. Let me just see if I can find them. Here they are. Yes, I found at least 4 excellent videos that we can watch about interest rates in general. And in particular, we can start with compound interest, which explains what we've been doing. This one, nominal and effective rates, we have to wait a little while for that one. But also these two really are more about interest rates in the economy. And so we can watch those today as well. The nominal and effective rate may have to wait till next time. So, all right, let's get these notes going. Just a quick review of what we've been doing. Okay, because I mean, sure, it's been a long weekend, and you might have started to forget what we're doing. Let me just quickly save this. Okay. Sorry about that. It's getting to be that time of the year. Yeah. We might start getting some sniffles. All right. So just a quick review. Now, we were talking about, we introduced some very important concepts. For example, principal is the amount of money that you're borrowing or lending. The interest rate is the percentage of the principal that you're paying on that loan. And as we discussed earlier, the interest rates in the economy right now are at very unusually low levels by historical standards. So this would be the ideal time to borrow a lot of money. If you, for example, let's say you were 35 and you decided it's time to buy your first house, this is the time to do it. It's not likely that interest rates will be this low again anytime soon. But on the other hand, if you're saving, you're getting very low rates of interest right now. And so that might make it more difficult to save for your retirement. So interest rates can help some groups and they can hurt others. They fluctuate over time, but they do change with the state of the economy. So they typically rise when the economy is doing very well. And they typically fall when the economy is not doing very well at all. Okay, so, if you see rates starting to rise, it may very well be that the reason for it is because the economy is starting to rebound. And so while you might not be happy about that, if it increases your cost of borrowing, it might also mean that there's more jobs out there, for example. And so interest rates affect pretty much every transaction in the economy. So this is an awfully important area of study. Now, we define simple interest to be interest paid on principal only. And the name tells it all. It's very simple and easy to calculate because all you need to know is, see, here it is. This is all you need to know to calculate your simple interest. The principal that you borrowed or lent, the interest rate, which is an annual rate, by the way, and T is time, measured either in full years or fractions of a year. Okay, so if you lend your money out for less than a year, T will be a fraction. Like 6 months, for example, would translate into 0.5 years. The rate of interest, it's understood that number is an annual rate. This is why it has to be adjusted to the actual time frame. And so in this very simple case we've seen earlier, an investor deposits $1,000 in a bank for 1 year, where the bank pays 3% interest. Well, now here's the thing though, with this example, keep in mind that the interest is being paid at the end of the year. We already saw that in practice, that's not the way it works. But in this simple example, suppose the bank waits to the end of the year to pay you your interest. Then you're going to earn $30 worth of interest because at the end of the year, 1,000 times 3% is equal to $30. That's simple interest. The balance in your account, of course, would be $1,030. That balance is often known as the future value. In other words, from today's perspective, how much will we have in the bank in the future? That's what we call future value. So this one, we can use two equivalent formulas to calculate it. The original principal of 1,000 plus the interest, or because we've already seen that I equals PRT, algebraically, there it is. Algebraically, when you combine these, this is the final result. So it's up to you to decide which formula to use. So in our simple case, we just add them up, and we know that we started with $1,000 for the principal. After a year, we earn $30 worth of interest, and then finally, when the year's over, we'll have $1,030 in our account. That is what we call the future value. As I mentioned, T can be a fraction if we deposit funds for less than a year. Here we have $1,000 deposited for only 6 months, and the rate is 4. So therefore, we're only going to earn $20. If we kept the money in the bank for the full year, we would have earned 40. But because it's only 6 months, you can see that we'll end up with $20. All right, now we then, if you might recall, took that I equals PRT formula and rearranged it multiple times to come up with formulas for solving for the other variables in this equation. Okay, so in other words, if you don't want to know I, if you already know I, but you're looking to solve for P, all you have to do is take this equation and, in this case, divide both sides by the variables that you don't need. So here, for example, I'm looking to solve for P, so I can divide out these two. And of course, these clearly cancel out. And so if I know I, R, and T, I can figure out how much principal must have either been borrowed or lent. Okay, and it's maybe more useful than it sounds. It may help us figure out, for example, what is the maximum we can borrow if we can afford to pay I dollars for interest. This might help us determine, like, say, the limit to how much we can borrow. So like when you're looking at new cars, for example, you don't really know how much you can afford. I mean, it's hard to say. You walk in the door and they say, well, we got this new car that you want and it's $25,000. Well, you know that you're going to pay it off with a loan, probably for 4 or 5, even 6 years. The question really is, how much interest are you going to pay? And even more important, how much is the monthly payment? So you might be able to use, maybe not this formula, but one of the later formulas to come up with a maximum price that you can pay for your car and still afford the monthly payments. But here, with only simple interest, really what you're limited to doing here is saying, well, how much can I afford to borrow? This is what's going to tell me that. Or it might be the other way around. You might say, well, I'd like to earn I dollars from keeping money in the bank. How much principal do I have to deposit in the bank? So you can do a lot of interesting things with this formula. So here, for example, we're told that a homeowner has paid $20,000 in simple interest when the rate was 4%, and it's a 5-year loan. How much money must he have borrowed? Which is equivalent to saying, what is the principal? So it's now, of course, up here on the top, you can see we've rearranged this formula and solved for P. And when you plug in the numbers, by the way, I just want to remind you one more time that even though R is 4%, you should never put that into a formula. Immediately convert it into 0.04. Okay. And if you've forgotten how this works, just go to your calculator and type 4/100, because that's what it means. 4/100 is 4%. Okay, so don't forget about that, because you'll definitely not get the right answer if you don't remember that. All right, so here this means that the homeowner must have borrowed $100,000. Well, in Westchester County, that's not that unusual. What if the house needs a new bathroom or something? Then we might be looking at a lot of money, 100 grand. Or, it's hard to say. It depends on where the house is. In some parts of the country, that might almost be enough to buy a new house. There are lots of interesting shows on TV about hunting for property in different parts of the country. And if you ever watch those shows, like House Hunters, what is it? I think it's actually called House Hunters, one of the shows. And you'd be shocked sometimes how little property actually costs in some parts of the country compared to this area. You get people looking at these nice big houses and they're selling for $200,000-300,000, and you want to know, where is this place that I want to move to? It's a very, very erratic, the cost of real estate throughout the country. So 100 grand might be peanuts in Westchester, and it might be an enormous amount of money in another part of the country. But anyway, I'm sure you all knew that. Real estate is unusually expensive in this part of the country. In fact, I think it's more expensive than almost anywhere else. The other cities that are really maybe even more expensive would be, I think, LA, San Francisco, Boston, and maybe Honolulu. We're way up at the top of the list, that's for sure. All right, anyway, so now suppose I need to know the rate of interest, the implied rate of interest that's being charged. If I'm told how much interest I have to pay on a loan, I know how much I borrowed and how much time I'm borrowing it for. Suppose that, just out of curiosity, you go to the auto dealer and they say, listen, you can have this brand new car and we'll charge you a monthly payment of $400. You may want to say to yourself, well, what kind of rate of interest does that represent? Well, for that, we would need a more complicated formula, but you may just say to yourself, I'm wondering how much interest they're really charging me. Oh, I know they gave me a contract, but the information is in tiny little print buried in a footnote on page 32. I just want to get a rough idea how much interest I'm really paying. Well, a formula like this could be very helpful. Okay, so again, you're just rearranging the original formula, algebraically solving for R. Let's say here an investor puts $1 million into a CD for 1 year, and the bank pays $20,000 worth of simple interest, which, by the way, is the amount of interest you would earn if the interest is only paid at the end of the year. Anything more common or frequent than that, and you're going to also earn some compound interest. And just a quick reminder, CD is simply a savings account where you can earn more interest simply by keeping the money there for a certain length of time. So like with a normal bank account, if you put in $1 million, you can have it back tomorrow if you want it. With a CD, you're committed to keeping it there for a year. If you do insist on having it back, oh, they'll give it to you, right? But they're going to hit you with a lot of penalties. And you'll be very sorry because it'll wipe out all of your interest and then some. So CDs are meant for people who are sure that they don't need the money for any great length of time. But if that's the case, then it's a great way to take advantage of the higher interest rates. Okay. All right. So here's the rate. So if you earn $20,000 on $1 million principal, that means you earn 0.02, which remember is the same thing as 2%. Now, here's an interesting little side note. This is what reminded me of it. You see the percent sign, 2% is equivalent to 0.02 because 2 over 100 is 0.02. Now, supposedly, the origin of the symbol for percent is that it's nothing but a rearrangement of 100. I don't think anybody knows if this is true or not, but that's one theory, at least, as to where this symbol comes from. It's a way of reminding you to divide it by 100. It might be true, it might not be. It might be an urban legend, I don't know, but it's kind of interesting how that worked out. A lot of symbols evolve over time, and after a while, people start to forget where they came from. In fact, it might surprise you to know that even the US dollar symbol, nobody is 100% sure where it comes from. Somewhere along the way, people just started using it, and all of a sudden it caught on, and there we are. And so there's nobody around who can tell us, yes, there's a specific reason why this was chosen, because nobody knows. Nobody thought to write it down. But there's evidence that this symbol has been used going back to the late 18th century, at which time historians have found grocery receipts that had this symbol written on them for the price of the groceries. But again, there's no mention of where this comes from. How do you like that? Is this surprising? I was surprised. I figured the US dollar is not a very old currency compared to some of the others around the world. And yet somehow that knowledge has been lost. All right, now the word term, remember, means time in this context. The term of a loan means how long before you have to pay it back. Or for CD, the term means how long you have to leave the money there. So here we can take our same starting equation, the simple interest equation, rearrange it and solve for t. So for something like this, you can see why this might be very helpful. You might say, well, if I need to earn I dollars, how long will it take me to get to that goal, given that I'm investing P dollars and I'm earning a rate of interest of R%? So this investor is depositing $100,000 into a CD that pays 3% per year. And at the end of the time period, the investor will have $30,000 in simple interest. We don't know how much compound interest unless we have more information, but the simple interest will be 30,000, which implies how long will it be before the CD matures? In other words, what is the term of the CD? Well, let's plug everything in, and you say, oh, there you go. It's exactly 10 years. It's a 10-year CD. Now, I don't know about you, but I'd be nervous putting my money in a 10-year CD. Who knows what might happen in the next 10 years? But they do exist for money that you really don't need. For example, what if this is your retirement money and you're not going to retire for 50 years? Well, then I guess it's okay to go ahead and do this. But it's one of these. This is probably the longest CD that they have because that's a very long time. Yes, percentages, don't forget, convert before you do any formulas. Just be careful with them. Sometimes it's easy to lose track of all those zeros. Now, by the way, some calculators have a percent button directly built into them. I'm going to see if ours does. Let me find out. I'm going to open it up right now. Hold on. If it's there, let's see. Oh my God. I found it. Okay. So on the iPhone calculator, which you all know and love, this can be found by hitting 5 followed by, and then there's a percentage sign in the upper right-hand corner there. If you look at your calculator, it's actually on the top row, almost all the way to the right. It's next to the division sign. So if you're not sure, you just type the number you have and hit this percentage button, and all of a sudden there's the correct decimal equivalent. This is very helpful for very small numbers where it might get confusing. What kind of number, how many decimals you really need. And yeah, when you get small numbers, it's easy for something to go wrong. All right, so just be aware of that it's right there. Hold on. Now, I don't think it goes both ways, though. Like, for example, if you started with 0.05, I don't think it can send you back to 5, but there shouldn't be no reason for that. Okay. Now, compound interest, this is what we're building up to. Now, compound interest is interest paid on interest. Okay, so normally, unless you only get paid interest once a year and you keep the money there for just a year, you normally will earn both compound and simple interest. Okay, and that's the case if you look around at all the banks out there. In fact, we can maybe see if there's information about this on the net. Okay. However, in practice, technically, a bank could choose to calculate and pay interest in any interval it wanted to. However, in practice, there's only a few that are actually used: annual, quarterly, monthly, and daily. And then, this is interesting because they're going to go through and show you how much you're actually earning. I like this example. This is a case where the bank is compounding quarterly. Let's look at this example. Let's say you start with 10,000. The rate of interest is 4%. And it's compounded quarterly. Okay, so now keep in mind, if they're going to do this quarterly, they're not going to pay you 4% every quarter. They're going to pay you 1/4 of that, or 1% per quarter. So after 1 quarter, you earned already $100. This is all simple interest, rather. That brings your balance up to $110,100. Now, at the end of the second quarter, because your starting balance is $10,100, you're actually going to earn $101, not $100. That extra dollar is compound interest because it's being paid on the $100 in interest you earned in quarter one. So the balance is growing a little more rapidly than you might have anticipated. Now, in the third quarter, your balance is $10,201. Now, 1% of that, is 102.10. Now, again, the simple interest would be $100. The remaining 210 is compound interest. And so we end up at the end of the third quarter with 10,303.10. And then in the beginning of the fourth quarter, we apply, or the end of the fourth quarter, we apply 1% interest to that, 103.03, which is which means the last 303 is compound interest. And therefore, at the end of the year, instead of having just $10,400, which is what you would get with simple interest, you've got $10,406.13. The last 613 is our compound interest. And they make the case here, sure, it's only 613, but it's still more money. Okay. Now, interestingly enough, here's the formula. It looks just like ours, doesn't it? Let me just go get our slides and show you. In fact, it's exactly the same. A, except they didn't call it A. P equals 1 plus R over N to the NT power. T is years, R is interest rate as a decimal, N is the compounding frequency, and P is the principal. In practice, they may pay monthly, but many of them do pay daily. For example, it says here, Bank of America, Wells Fargo do it daily. Chase pays monthly. So, but the bottom line is none of them are paying you on an annual basis. And by the way, in order for Chase, if they're only paying monthly, they have to actually pay slightly more interest to compensate you for the loss of compound interest. So you'll end up earning the same interest any way you look at it. All right, anyway, this is a website that I happen to know, and I like it a great deal. In spite of the ridiculous name, The Motley Fool, if you need information about finance, this is a great source because they often have a lot of interesting articles about what's going on in the economy and in particular, what's going on in the stock market. So if that excites you, or down the road when you're working and earning money that you want to invest, this is a great place to start reading up and learning about what's happening in the real world. In fact, I'll tell you what I'm going to do. Let me send you a copy of this article. I like it so much that I think you should have it. Okay. Oh, so Juliet, I have your message. Okay. So there it is. Why don't you hang on to that because I think it's a great article. Okay. There we are. So anyway, let's get back to this. Now, this formula is needed. The only time, by the way, just remember too, this formula up here is for simple interest only, which implies annual compounding. This is what happens in practice. This is the one you need. And again, the only new piece here is the compounding frequency, which, like they said in the article, in fact, here, the only one that's missing is quarterly. It didn't mention semi-annual, I noticed. They're basically telling us that in the real world, yeah, that's all they're showing us, but semi-annual means twice a year, in case you run into that. Most of the time, they're saying here that that's going to be annual, quarterly, monthly, or daily. All right, so I think we may have started to do this already. It's good calculator practice. Make sure you know how to calculate these numbers. You have $1,000 going into a one-year CD. The rate is 4%. Just like, oh my God, it's just like this one, except that it's 1,000 instead of 10,000. So basically, our numbers should be, oh, but okay, so let's jump ahead to the quarterly example. Oh no, we didn't do quarterly. That's right. This is the quarterly example. We did annual. Now with annual, you're leaving the money just for 1 year. You're getting interest once. There's not going to be any simple interest. Sorry, there's not going to be any compound interest. There's only simple, $40. And no matter how long we leave the money in the bank, we're going to get $40 a year in simple interest. Now, once we hit anything else, the future value goes up because of the compounding effect, as they're showing you in this chart. You're getting paid interest more than once a year. Therefore, during the year, some of your interest is being credited on both principal and interest. And that's where this is coming from. So it's not a huge amount. Like they said here, look, it's only 613, but it's still more money than you would have otherwise. And you wouldn't give this money back to the bank because it's so low. You just take it. And keep in mind that the more frequently interest is compounded, the more compound interest will earn. So with semi-annual, that went up to 40 cents worth of compound interest. Now, if you plug the numbers into this formula, by the way, I think we went over this already. You should ideally try to simplify this as much as possible. This is a very complicated formula, the way it's written. If you try to do this the way it's written, you'll probably make mistakes. So what you can do is say, well, 0.04 over 2 is just 0.02. I add that to the 1. The exponent is 2 times 1, which is 2. So what I recommend you do is always start with the most complex part of any formula, meaning this in the box, and then whatever that is, multiply by 1,000. You don't have to go from left to right, even though that's what we're used to. If you go from left to right, in this case, it'll be more complicated. So maybe start with this part on the right and then multiply by 1,000. And so anything above 1040 is going to be our compound interest. Now, when we jumped up to monthly, you can see the amount went up again from 1040.40 to 1040.74. So therefore, the change in that last 34 extra cents is the additional compound interest we earned because the compounding frequency jumped up from 2 to 12 rather. So every time we increase n, we expect the compound interest to go up. When we jumped up to daily, you can see it went up a little bit more. Now this was a really messy expression. 0.04 over 365 is a tiny, tiny little number, which when added to 1 gives us approximately 1.000109589. We raise that to the 365th power, and that worked out to be roughly 1.040808, which when multiplied by 1,000 gives us our final result. It's not much higher, is it? About 6 cents more than when we had monthly compounding, which may seem very disappointing. You figure when you go from 12 to 365, the compound interest should go up quite a bit, but it doesn't actually work that way. And in fact, I put together a little table here, as you can see, for different compounding frequencies. The simple interest never changes. The total interest goes up because the compound interest is going up. Okay, so remember, the total interest, oh, wait a minute. You know what? I just realized this is not total interest, is it? Oh, I just realized this is a mistake. That's the final balance. That's what I get for rushing it. Let me fix this real fast. That's the future value. The total interest, sorry about that. Yep, okay. Let me shrink up the text just a little bit. So if it's, okay, so here the total interest is 40. Okay, this is the future, the total interest is compound plus simple. Now we're getting somewhere. Now the table is accurate, excellent. But what I want you to see is the relationship between the frequency and all these variables except simple interest. And even then, I want you to note that the simple interest never changes. It's these three, and they're all being driven by the compound interest. When that goes up, total interest has to go up, and therefore so does the future value. But there comes a point where there's some kind of a limit that will be reached. In other words, if I change this to hourly compounding, the increase would be so trivial, it would not, it would disappear, let's say, when you rounded it to dollars and cents. So if I decide to get really carried away, suppose my bank says to the, they advertise in the New York Times, oh my God, look at us. We're the first bank ever to have us compounding every second. Come to us, please. Well, you would sit down with your calculator and say, that only means a difference of a fraction of a cent. So I'm going to keep my money where it is. So this is pretty much in practice the limit to how much compound interest we can earn. And I drew a little picture here to show you that you see what's happening as we increase the frequency. The compound interest at first increases fairly quickly, and then it sort of tapers off. And that's what this graph is trying to show. And this is happening because the compound interest increases at a decreasing rate, we call it. It's kind of like, it's almost like saying that you're driving along towards a red light and you're still going forward, but you're slowing down as you approach the light. And so if you can imagine that this number right here, whatever it is the red light. It's like, this is a car that's going fast. Whoa, wait a minute, I see the red light. And you start to slow down, and then you stop eventually at the red light. I don't know, that's the best I could do at a moment's notice. But yes, you get the idea here. So calculating the compound interest, basically, we do not want to calculate it directly. If you look at this table, we don't need to. In other words, if I have these three numbers, in fact, all I really need, well, let's just put it this way. If I know these three numbers, I can automatically calculate the compound interest. It's just the difference between these two numbers. So that's the approach we're going to take. We're not going to have a formula for compound interest. It would be too messy. Instead, we'll do the simpler case. We'll calculate total interest. We'll figure out how much of that was simple, and whatever's left over must be compound. Okay, let's see. So we may have done this example. I don't actually remember, but what if we borrowed $10,000 for 3 years? The annual rate is 6%, but it's compounded monthly. First, how much interest will the borrower pay during the lifetime of the loan? So basically what that means is the future value minus the principal equals the total interest. Okay, so in other words, A minus P would be total interest. So we're going to use our A formula to figure out the future value first, then we'll subtract the principal, and what's left over is our total interest, which we can then break down into both simple and compound interest. Okay, let's look at it. So P is $10,000. We borrowed 10. Their annual rate is 6%. It's a 3-year loan, and it's compounded monthly. That's why N is 12, because this is monthly compounding. All right, well, if you plug these numbers, now, by the way, once again, like I always recommend, when you plug them in, what I would recommend you do is take this 0.06 divided by 12, which you can see is 0.005 or 0.5%. And then the exponent is 12 times 3 or 36 months. Now, let me just, I see that it's not listed here. Let me just quickly do this. All right, let's see, 1.005 raised to the 36th power is 1.196681. And then when I multiply that by $10,000, that's where this comes from. The future value. In other words, if I'm borrowing this money, I'm going to end up paying back to the bank $11,966.81. Okay. Well, how much of that is interest? Well, since we borrowed $10,000, it must be the case. Let's jump ahead here that I must have paid 1,000. Wait a minute. Oh no, that's something else. So the total interest is 1966.81. But we can decompose, let me do this. Let me move this on to another slide so it's not so confusing. Here in this slide, I just want you to see that the total interest is 1966.81. Okay, so let's repeat that. Give it a second. Oh man, what's going on here? Here it is. Yeah, it was being stubborn for a second. So total interest is 1966. The simple interest, I equals PRT, is 10,000 times 6% for 3 years equals 1,800, which means that the compound interest is simply total interest minus simple interest equals 1966.81 minus 1,800, which ends up at 166.81. And that's all you have to do. All right. So now, with that being said, we're ready to watch some videos. And then when we're done with that, we'll come back to this discussion about the so-called effective rate and the annual rate of interest. This is kind of interesting because if you've ever been in a bank, ever in your life, you may not have been paying close attention to the interest rates that they have posted there. With ATMs, it's gotten to the point where you almost never have to actually walk inside of a bank unless you really want to. But if you do, there'll typically be signs all over the place advertising the interest rates that they pay on their deposit accounts and on their other products, plus how much does it cost to borrow for a car loan, for example. The interesting part is that there's typically 2 rates of interest quoted for each product. So we want to ask ourselves, how and why is this happening? And what does it mean? So that's coming up next. But before we do that, let's have some fun with these videos. All right, so we'll start. This one is all about compound interest. The 2 after that are more about, let's say, how interest rates are determined in the economy, which I think is extremely interesting. And if you've ever had a course in economics, you may have already had some familiarity with this. In fact, oh crap. All right. Can everyone still hear me?
Yeah, we can hear you.
All right, but it seems to not be working right now. Can you see what I'm doing? Can you see that I'm on Moodle?
Yeah, we can see Moodle.
So this is so weird because it looks like all the controls are not functioning properly. Like, for example, I don't have access to the chat room. It's just this weird mode. So I think I'm going to have to stop the recording right now and start it again. So hold on 1 minute. I'll see what I can do here. I'm not even sure. I might have to reboot my computer. Oh, this is not the first time this has happened. It's very weird. All right, I'll tell you what. Why don't I reboot my computer? And then we'll start up again. Last few times this happened, we only needed to do this once. So, all right, hang on while I take care of this.